Okay. All right. I think this is good. I can hear myself. I hope you can too. All right. Hello, everyone. Thank you for being here. It's a good crowd. This is nice. And I hope there is a good crowd online as well. So that's nice. Okay, so I'm going to start by reading the house rules. So closed captioning is available via real-time transcription card. And to enable the captions, those online should click on the CCC button located at the bottom of the screen. And in the question period will be conducted using the hand-raising function, this function, as much as possible. Alternatively, if you cannot or prefer not to unmute though online, please use the Q&A function to type in your question. And to ask a question, click the raise hand button, wait for your name to be called. You're going to get an unmute confirmation, and you have to agree to be unmuted before you begin to speak if you choose to speak your answer, or it's going to be read from the chat. And if you have any technical issues, send them through the chat then. All right, thank you. And then next, an important thing. All right, so the Department of Linguistics recognizes the University of Michigan's origins in a land grant from the Anishinaabe, including Ottawa, Ojibwe, and Potawatomi, and Wyandot. The university continues to exist on the historical territorial land of the Anishinaabe people. Ottawa, Ojibwe, and Potawatomi are collectively called Anishinaabemowin and belong to the Algonquian language family. There are currently 12 recognized Anishinaabe tribes in the state of Michigan, and many Anishinaabe people living throughout the state and interacting at the University of Michigan. All right, so I have the pleasure to introduce the first presenter to our graduate colloquium today, Aliaksei Akimenka, Alex Akimenka. Alex is a PhD candidate in linguistics. He does research in syntax and syntax-semantics interface. And he's currently finishing his dissertation. The committee includes Natasha Ebner, Ezra Keshet, and Teresa Satterfield. And Alex also has a BA in linguistics and translation, and an MA in philology from Minsk State Linguistic University in Belarus. He's also a speaker of Belarusian, Russian, Ukrainian, and German. He holds a graduate certificate in CogSci from the Weinberg Institute of Cognitive Science. Alex has been very active presenting his research, the research he's doing for his dissertation at conferences for several years now. He has 2 papers on topics of his dissertation. They have appeared in the proceedings of the 59th proceedings of the Chicago Linguistic Society, the last one, including the last year's. And he has presented 3 times at CLS. He also has a paper in the proceedings of the West Coast Formal Conference, Conference on Formal Linguistics. In addition to that, he has presented his research twice at the annual Pan-Linguistics Conference at GLOW in Asia, and he presented 3 times at the annual meeting of the Linguistic Society of America. So pretty much out there, and I think people know his work on the topic that he's going to be talking about on his dissertation. So welcome, join me in welcoming Alex to give his presentation today. So is there, against this school in here? Yeah. Just there, okay. Yes, okay.
Thank you, Akrizio, and thank you for joining my talk today. And thank you for inviting me to present part of my dissertation project. Today, I will be talking about okay, yeah, it works. Today I'll be talking about a movement, and we'll try to rethink a movement in raising to object constructions without making recurse to internal merge. So this talk has 2 small parts. The first one, in the first one, we'll briefly discuss direct and emergent processes and the differences between them. And in the second part, we'll try to reconceptualize a movement in the derivation of phrase into object constructions as an emergent process rather than direct process. Okay, so I'll start with this pretty boring table, which briefly summarizes the differences between direct and emergent processes. So I summarize the main points in the yellow blocks. Unlike direct processes, emergent processes are system-wide. This means they have no clear cause and effect explanation. So if in the direct process, we can have a single agent that can directly cause the global pattern or the observable pattern. In the emergent processes, they have different agents, and they are working to achieve local goals only, and they do not have any intention to achieve the global goal, and the global goal itself emerges from these local interactions indirectly. And what is most interesting, in emergent processes, agents can interact, and most often they interact in disjoint or non-matching ways. I can have one example, and this is highlighted in Binder's paper. According to his claim, the common thread between all complex systems, including language, may not be cooperation, but rather irresolvable coexistence of opposing tendencies. I have one example of an emergent process from physics. So atomic magnets can spin either up and down. And imagine a situation when we have these particles arranged in a triangle, and we have a requirement that each one must spin in the opposite direction to its two neighbors. And the problem is that we cannot have an arrangement which can reach this goal. And the system, in this case, appears to be a frustrated state. This is an example of geometrical frustration. And the tension itself between two opposing requirements can non-linearly generate new emergent properties. As balance observed in physics, a little frustration can make life interesting, as it under certain conditions promotes the emergence of exotic properties of materials such as quantum spin and liquids. So we have two opposing tendencies here. So this one requires this spin to look up, and this spin requires to look this one down. And the tug of war between these two opposing tendencies can give rise to the emergence of new properties. Another example is the predator-prey cycles. So the proportion in most ecosystems, the proportion between the predators and prey remains constant. And this is not because predators intentionally control their appetite or prey intentionally control their reproduction. Again, so they actually try to fulfill their local goals, like the predators want to satisfy their hunger, and the prey wants to reproduce. And these opposing tendencies between the tug of war between predators and prey actually give rise to these cycles. Okay, before starting talking about movement in syntax, let's talk a little bit about physical movement. And physical movement is often represented as a direct process. So why do things move? Actually, nothing in the properties of this object can help us answer that question. So in order to do this, we can postulate an invisible force. This is what Newton's first law of motion does. So a stationary object cannot move unless it is acted upon an external force. But as philosopher Colin McGinn observes in this respect, one problem with these invisible forces is that they are, first of all, they are invisible, and second of all, they are ad hoc postulations. So we have no evidence for the existence of these forces except for movement they produce. And what is most important for us, this force does not explain anything. It just repeats what we have already observed, like the effects of dislocation. And this direct process underlie the so-called intuitive theories, and intuitive theories like to deal with uncertainty by postulating these hidden causes to explain the observable effects. And one problem with intuitive theories that they very often prevent us from understanding the true nature of things. As Epstein and Seeley argue, if you have not grown it, you have not explained it. So how is syntactic movement different in this respect? So when we talk about movement in natural languages, we usually talk about situations when some constituents appear in a position in which they are not semantically interpreted. So take this example, the Cheshire cat seems to grin. The cat actually the logical subject of grin, but in the surface structure, it appears as the subject of seems. So we might conclude that the cat must have moved. Movement in minimalism, at least, now follows from the basic operation merge. So we can get movement for free. Merge takes two input, as an input, two categories and puts them together in a set. And the attractiveness of this hypothesis is that any grammar that has merged can also have some sort of dislocation operation for free. So in order to derive the cat seems to grin, we can first merge the cat into green and form a new syntactic object, the cat to green. As the second step, we can merge the cat to green with seems and get seems the cat to green. But note that nothing in principle prevents us from merging a constituent that has already been used in the structure. So instead of in the third step, instead of merging a new lexical item, we can remerge the cat from this position and merge it with seems the cat to green by leaving a trace or a copy in the original position. But even though this gets us movement for free, this still doesn't answer the question, how can merge trigger movement? And this is not a trivial question. As Lasnik observed, the major minimalist concern involves the driving force for syntactic movement, because given the leading idea of economy underlying the minimalist program, movement must happen for a reason. So similar to physical movement, what needs to be added here is a movement trigger. So, and we have a bunch of them, case, EPP, or labeling. And now we can have a direct or intuitive theory of process of dislocation in natural languages. It's very similar to physical movement. And ironically, all that McGinn noted with respect to physical movement perfectly applies to movement in natural languages. I mean, those forces in the first place. So they are ad hoc postulation, at least case and EPP labeling in a lesser degree. And there is no evidence for the existence of these forces except for the movement they produce. And what is most important, they do not add or explain anything. They just repeat what we have already knew or observed. So how can we get rid of this dubious force? And one way to do this is to try to rethink movement as an emergent process. And this has already been done in physics, where gravity has been reanalyzed as an emergent force. Because what looks like a direct force is actually emergent from the space-time curvature. So we can get rid of this ad hoc force. And the object here is actually moving on a straight line, but in the curved space-time. So can we also rethink syntactic movement as an emergent process? And this is the goal of the second part of this talk. I'm going to propose that raising to object in the raising to object constructions, the movement of the infinitival subject is actually moves into the matrix clause, and this movement is actually byproduct of structure building operation. Raising to object verbs have been widely analyzed as preposition taking because most of them are attitude verbs, and they are synonymous with their finite counterparts. And at the same time, these complements can be evaluated with the truth or falsity. So we can say still we believe syntax to be boring, which is false or true. I don't know. One interesting fact about this construction, we don't have any evidence in the word syntax of evidence of movement of the infinitival subject, but we have some indirect evidence for this. For instance, one piece of evidence comes from Lasnik and Saito, who famously observed that subjects of that clauses and their infinitival counterparts differ in their binding potential. So the judgments between the judgments are pretty murky, but at least free A is supposed to be better than free B, and this is expected if defendants would be in the matrix clause at some level of representation, because during each of the trials is an adjunct modifying proof, and reciprocal each other is inside this adjunct. So in order for the defendants to bind each other, defendants must be as low as in the specifier of matrix VP, namely proof. We also have some evidence from scope ambiguity. We all know that the intentional scope of attitude verbs is the complement clause. So embedded arguments should take narrow scope. They should be interpreted in the possible world, and the matrix argument would take scope over the attitude predicates, so they would be interpreted in the actual world. And in this example, Poirot proved two collaborators to have robbed the bank. Two collaborators can have a narrow scope interpretation. This is predicted if this is inside if two collaborators is the subject of the embedded clause. And we can compare it with the control construction. Poirot persuaded two collaborators to rob the bank, where two collaborators is takes scope over is a matrix argument, and it takes scope over the matrix verb. So we have difference between specific and non-specific interpretation. So in 4, Poirot proved two collaborators to have robbed the bank. Poirot might not know the identity of these collaborators. Maybe he simply identified two sets of footprints. But in this example, the identity of these collaborators is known, so maybe Jack and Mike. But what is interesting, so the 4 can also have an interpretation, two collaborators, and this interpretation might be even more preferable. So it can two collaborators might also have a specific interpretation. And this scope ambiguity can be expected if we have two copies of NPs in the sentence. So one is inside the complement, which would derive the narrow scope interpretation, and one which is outside this complement, which is in the matrix clause, which would derive the wide scope interpretation. So how can we get two identical NPs in a sentence? The traditional answer is by A moving the infinitival subject into the higher VP, giving rise to what Chomsky calls very strange raising to object phenomenon. So this raising can happen either in overt syntax or in the covert component. I'm not going to discuss the differences between these two hypotheses. So let's assume that under the direct theory, under the intuitive theory of syntactic movement as a direct process, we can put something on belief. So beliefs are has some property like EPP, which triggers the movement of infinitival subject, and we can create a specifier here. And now syntax is high enough to account for all those effects. But let's imagine a world without a movement. A lot of interesting facts, especially within the raising to object constructions, would suggest that a movement account of this construction might not be the correct one. I think I don't have time to discuss them now. So let us assume the working hypothesis that a movement does not exist as an independent direct process, and all noun phrases merge directly in their surface position. So what does this imply for our theory of raising to object in this case? Let's take our familiar example. Still, we believe syntax to be boring. Under this hypothesis, syntax would be merged, this NP syntax would be merged directly in the specifier of TP. And the question arises, what kind of T is this? Because it's neither present nor past. And several authors have argued that in ECM infinitives involve a semantically zero tense, which cannot license eventive predicates. And the question arises, why do we have this semantically zero T if in the first place, if it does not contribute to the interpretation? So my assumption is, my proposal, the presence of T is motivated by the selectional properties of belief. Remember, all raising predicates are additive verbs, and they all select, S selects a propositional argument at the semantic interface. So we have a constraint like S selection operating at the semantic interface, and S selection requires that the complement of belief be a propositional argument. And I'm proposing that syntactically proposition corresponds to a TP. I'm adopting the Kierkegaard's model of intentional logic, according to which there are three subdomains: properties, entities, and propositions. Properties can be predicated of other entities, but for properties to be predicated, they need a special predication relation. And this relation is introduced by tense. And the tense actually connect properties to their subjects. So this operation will take a property and get a propositional function. But what is interesting, the crucial component of Kierkegaard's theory is that it also has an inverse of this up operation, which function that takes a propositional function and turn it back into property. And this will become relevant in a moment. So under this theory, the function of the zero T here is just the introduction of this predication relation. So infinitival phrase is a property. And in order to introduce the subject of syntax here, we need to turn this property into a propositional function. And by merging infinitival phrase with T, we create a propositional function which can be saturated by the subject and P syntax. But now note that at the same time, we have another constraint, which is the familiar, maybe to some of you, the full interpretation, according to which all elements that appear in the interfaces, on the interfaces must be interpretable. So they must receive, they must receive an interpretation. And the problem, remember, this T is semantically zero, so it cannot reach the interface. If it reaches the interface, it would violate full interpretation. So one way to satisfy full interpretation at the semantic interface would be delete this T somewhere here on the way to the semantic interface. But what does it technically mean for a tense to be, for the tense to be deleted? I'm assuming Müller's theory, according to which syntactic derivations have two elementary operations. One is merge, the familiar merge, which builds structure, and the other one remove, which removes structure. So merge can apply to heads and specifiers, and for us, it would be interesting to consider what happens to the structure if the head is removed. According to Müller, if the head Y is removed from this hypothetical structure, the whole projection ceases to exist. That means that we must delete the whole projection. And this makes sense because the projection cannot exist without a head. A more interesting question is what happens to the material which was originally included into this disappearing projection, like the specifiers and complements. And I'm assuming, following Müller, this material must be reassociated in the original hierarchical order within the projection of the immediately C-commanding head. In this case, this head is X. So after we apply the deletion process, this projection goes away, and now the specifier of Y becomes the specifier of X, and the complement of Y becomes the complement of X. And note that this allows for ZP to enter in U domain without actual movement. So we don't need a triggered internal merge to create this specifier of, to create a new specifier of X. This is some sort of movement through the wormhole. I would like to make a break here and talk a little bit about some analogies from biology. So Müller himself asks, does it make sense for syntactic derivations to first build structure and then remove it again? And I think his answer is pretty compelling. He argues that it's not the case that merge exists, so that syntactic structures can be built. Rather, merge exists, and as a consequence, it can be used for structure building. And there is no reason why bigger structures would be preferable to smaller ones. And in the context of bilinguistic program, I would like to draw parallel between the similar operation in biology, which is called programmed cell deletion. What it does is that at some point, if cells are not longer required by the organism, they can commit suicide by activating a death program. So in a healthy adult human, billions of healthy cells die in the bone marrow every hour as a result of this programmed cell deletion. And what is more important, programmed cell deletion involved in developing new structures. So for instance, it eliminates the tissue, the interdigital tissue between the development regions in the embryos of invertebrates. And in this picture, you can see a mouse paw sculpted by self-death by development during the embryonic development. And likewise, various structures that serve transient function, for instance, the tail of the tadpole, are removed by PCD, then they are no longer required by the organism. So as a tadpole changes into a frog, the cells in a tadpole tail undergo PCD and the tail is lost. So I would like to suggest that remove in the context of bilinguistic program is similar to programmed cell deletion, and it can be considered as an evolutionary adaptation that evolved than merge. An original instrument of thought was a product of mutation, was adopted for communication purposes. This is similar to Hasaka's proposal that internal merge was evolved later than merge itself. Okay, so going back to our syntactic structure, remember we stopped here when we have merged this T and created a propositional function, and this propositional function was saturated by NP syntax. And now full interpretation requires that this T must be deleted in the component by applying remove. And we can compare this T and the deletion operation similar to removal of the tail in tadpole. So this structure served a transit function. So it was required to introduce NP syntax into the structure. And now it served this goal, and now it can go away. So remember that this actually captures, you see that NP, as a result of this removal operation, appears in the specifier of matrix V, but we did not use any movement operation to do this. So this is actually a side effect of structure removal rather than an instance of internal merge triggered by case or EPP. So now we can get rid of this dubious force, and we can rethink a movement in raising to object constructions as a emergent process. So we have a tension between two agents like merge and remove, and they try to achieve their own goal on one level. So they do not care about this dislocation operation. Merge cares only about merging structures, and remove cares only about deleting structures. But the actual pattern arises as a result of this tug of war between merge and remove. Yes, and the pattern arises from the local disjoin operation between merge and remove. I have some evidence for this, but I think I don't have time to discuss them. I will leave this for Q&A period. I would also like to discuss the scope ambiguity. Remember that the idea of the central idea on the central proposal to derive the scope ambiguity of this sentence was that we have two NPs in the sentence, and one of the copies is derived by movement. But note, what we don't have any movement, we have only one NP here, which was derived via structure removal. So this raises the question, how do we derive scope ambiguity in this case? So my proposal is that, again, so this scope ambiguity is an emergent process, and it arises as an interaction, disjoint interaction between two constraints operating at the semantic interface, full interpretation and S selection. So I would be happy to discuss this in the Q&A period. So I would like to thank my advisor, Aliaksei Akimenka, my dissertation committee, and all of my friends for discussions of different syntactic topics that have taken place over these years, both inside and outside the scope of the graduate lunch. Thank you.
I really enjoyed the talk. This is not so much a question as it's a comment that what I particularly like is the tension that lets you emerge, that you have properties emerge from, in part because that's what we see in syllable structure. Gestural timing is exactly the competition between certain kinds of gestural timing. So I really like to see that in syntax. And I hope somebody else will ask about your scope ambiguities, how the properties emerge, but that's not my question. I'll let that the syntactician ask that.
Thank you so much, Alex, for this very interesting talk. I really learned a lot from it. So one of the things that I was thinking about is how your theory now may have some implications for language acquisition. Like, how can we learn from language acquisition, like by employing your analysis?
That's an interesting question, and I need to think about it. I actually don't know, because I was really involved in thinking about how we can conceptualize different processes. And I think that, like, as someone said, all models are wrong and some models are just useful. So I agree that even my model is wrong. I'm just thinking about, so the goal of my research project was to try to come up with more explanatory power. And you give me a good idea to think about, like how all this theory can be incorporated into language acquisition.
Because I was thinking about whether you're generalizing all the A movement or you're just really looking at the raise to object phenomenon, because
Yeah, oh, I see. I think this is a research program. So I think it could be really interesting to think about all instances of A movement to see how they can be derived as emergent processes. But for this particular part of my dissertation, I'm looking only at raising to object constructions.
yeah, I'm sorry. I know this is not your strong suit. I'm just coming from a acquisition side of it. And I was trying to see whether this approach can align with some of the difficulties that children might have when they learn this kind of particular A movement. At least I know for passive, some people have said like it might be challenging for kids. So I don't know whether your approach can apply to those. So that was something that I'm interested about.
Well, technically, we don't have to learn if we assume that, at least for raising to object constructions, like the acquisition of them, like we don't have any evidence in the word syntax for raising, right? We have indirect evidence based on the interpretation that the infinitival subject must be higher in the structure. And if we assume that merge is innate, and then this remove operation is also innate because it just evolves as evolutionary adaptation, then I think it makes acquisition much easier.
Thank you.
Thank you, Lucy.
Thank you, Alex, for the amazing work. I just wonder, I have a question about the non-movement approach and how this can be applied to other dependencies, like long distance dependencies, say the gap or the presumptive A-bar dependencies in constituents questions and relative clauses, for example. And can we apply, does this theory have the potential to be applied in these kind of structures? And what about languages which show sensitivity, for example, to islands, and they show weak crossover effects? And it's proposed that these kind of languages, the long distance dependencies in these languages, are formed through feature-driven movement. I know you hate the word feature. You might leave the room when we say feature. So, yeah.
I don't know if this approach can be applied, because I'm talking about A movement. I don't know if this approach can be applied to derive A-bar movement or long distance dependencies, which are supposed to be derived by A-bar movement. But the second part of my dissertation is tough constructions, and at least it has been argued in the literature that tough constructions constitute long-distance dependencies. And I think you're familiar with that approach, according to which I derive the long-distance dependencies. It is possible to derive the possible long-distance dependencies in tough constructions without invoking A-bar movement. I'm proposing that they can be derived by prolapsus configuration. So I think this is possible, but at least for some constructions. Thank you.
I think we have time for last question.
I have a question about the phonetics. Sorry, semantics. If you can believe it. So originally you say that the T has a meaning, which is the up function to turn. I mean, that's a meaning, right? Because it's semantically changing something from one semantic category to another semantic category. But is that not the kind of meaning that counts for full interpretation? So I'm just wondering why the T needs to be deleted for full interpretation if it seems to have what looks like, at least on the surface, a semantic meaning.
I mean, the idea, the original idea is that this T in this E raising to object complements is semantically zero tense. And I agree that this raises some question as to, like, yeah, so you have to have this T, and this T is introduced in the new semantic category like a propositional function, right? And at the same time is semantically zero, and it has to be deleted. I need to think about this. I agree this is a valid concern, but yeah.
I wonder if it'd be simpler if the explanation for its original presence was more syntactic rather than semantic, and then that would, and we can just talk offline about it and stuff. Yeah, I'm also interested in what the meaning of the verb believe is in the full.
Thank you as well.
Thank you for your questions.
I'm sorry not to be joining you guys in person today. I really want to thank Alex for a wonderful talk, and I have the pleasure of introducing the next speaker, Jeonghwa. Jeonghwa completed her master's degree at Seoul National University. I had the pleasure of meeting her while she was completing her studies on the phenomena of aspectual coercion, which is a cousin of the up and down operators in the event domain of that Alex was just teaching us about. Jeonghwa then joined our program and has become an expert in the psycholinguistics of bilingualism. And there's just so much that she has been developing in that domain. One thing that you'll see in the work she presents today, and one thing that I hope you see in the work that she will be defending from her dissertation on Tuesday at 10 a.m. in Lorch 403, for those of you who need an extra reminder to join us for that wonderful defense on Tuesday. One thing you'll see in Jeonghwa's work is the amazing amount of breadth that she brings to bear on the theoretical questions of how speakers of multiple languages navigate these multiple languages. The breadth of tools she brings are all focused on attention between the particular of individual languages and the universality of humans processing these languages. And psycholinguistic theory has not directly confronted that tension in the past. Psycholinguistic theory tends to talk about things like accessing words or processing sentences as if that's a single thing that happens in the same way for all language users across all languages. And that might be right, but the words of different languages and the syntactic structures of different languages are on the surface very different. So understanding what those processing mechanisms are as they apply to these varied linguistic phenomena that we observe is attention. It's attention that Jeonghwa confronts very directly. One thing that stands out about the way she confronts that tension is she brings a huge number of tools to bear. And the way she finds these tools has always been so impressive to me, and it's brought a lot of richness to the work that we do more broadly in the lab, because she finds the tools that are right fit for the question. So rather than saying, I have an EEG system, let me see what I can do with EEG, she confronts the phenomena she wants to investigate, thinks about what the key debates are, what the questions are, and identifies what is the right sort of data, the right sort of analysis tool set that will help her make progress to the next step. And that's brought a lot of new tools into our repertoire as a laboratory. So I've already spoken probably a little longer than I hoped. I'm again sorry I can't be there, but it's my great pleasure at this point to introduce Jeonghwa Cho. Thank you.
All right. Thank you, John, for just wonderful introduction. That's almost flattering. And thank you, everyone, for being here. So I want to start my talk with a quote that became one of my favorites. So psycholinguists, if they are to make universal claims, in this case about language processing mechanisms, they should not restrict themselves to studying just English. So this is what my research is coming from in general. So as you might be all aware of, there's many different aspects that different languages can be different. But today I'm focusing on the difference in the word order and the morphological systems. So English is an SVO language where the object comes before the verb, but that's not the case for all the languages in the world. So for example, we have Korean or in Japanese, among others, that are in the SOV order, where rather the object comes before the verb. So in most of the sentences, the verb comes at the last position of the sentence. And these differences alone have been found to lead to different mechanisms while processing sentences, both in production and comprehension. So during production, English speakers may rely on the verb information during sentence production, but not so much for Korean speakers. And similarly for comprehension, verbs may play different roles in head initial versus head final languages. So in head initial languages like English, verbs are argued to play a central role in building argument structures. But whether this account holds the same way for other kinds of languages, especially head final languages, is yet unclear. So today I'm gonna present results from 2 experiments, which is a part of my dissertation. So first on the production, so that's experiment 1, cross-linguistic investigation on the role of verbs during sentence planning. And second experiment on comprehension, so the timing of verb activation during sentence comprehension. Okay, so before I begin the first experiment, I would like you to do some activities. So here I'll play a video clip where you will see 3 different images. So there will be a subject, an action, and an object. And I would like you to look at those images and construct a sentence, okay? In the language that you are most comfortable with. Visual, get it? So the sentence in English would be something like a part its or ate a pear, right? Okay, here's another one, same activity, but with different set of images. So this one might have been more difficult. But the target sentence for this case was the painter smiled or laughed on the stage. Okay, so if you think about your thought processes to construct those sentences, do you think you might have gone through different processes for the first trial and the second trial, or do you think they were the same? And if you speak any other language, like if you were to speak in the other language, would it be also the same or different? So that's the questions that I asked for this experiment. So first, how do we plan sentence production in general? And specifically, I focus on the process of generating a pre-verbal message until speech onset. So that's when you actually began speaking, like began producing the first word of the sentence. Oops. And how does this process interact with the canonical word order of the language to speak? So to give you some theoretical background on sentence planning, there have been two different hypotheses that have been presented. So first is the linear incrementality. So according to this hypothesis, speakers plan a sentence in a linear order of the surface form. So they can start speaking as soon as the first elements of a sentence are available without necessarily knowing the later part of the sentence. The other one is the hierarchical incrementality. So according to this hypothesis, speakers cannot start a sentence based on a single constituent of the sentence, but they need at least a rough idea of the whole sentence. But then these theories also might interact with the word order of the language. So especially for the role of verbs, so English speakers need to access verbs before speaking, but Korean and Japanese speakers have been found that that's not the case. They might not need such early verb access. So I'll show one example from a previous study. So in this study, there were both Korean speakers and English speakers, and what the participants had to do was look at an image like this one and say a sentence like a clown arrests a giraffe in this case. And while they were doing it, they had to also hear some distractor words, related word to any of the words in the sentence, and a word that's related to the verb here, and another word that's related to the object. And then when they measured the speech onset latencies, so that's the time it takes from the image onset to actually speaking the sentence, English speakers got interference effect from the verb-related distractor, but that was not found for Korean speakers. So this indicates that for English speakers only, they had earlier access to the verb already before speaking the sentence, but not for the Korean speakers. And the similar pattern was found for eye movement data. So this part before the dashed line is when speakers were looking at the image right before the speech onsets. And you can see this little bump for the verb image, again, only for the English speakers, not Korean speakers. So altogether, this suggests that English speakers rely on the verb more than Korean speakers. But then one limitation of the study is that they only looked at this transitive sentence and not other types of sentences. So in my study, I asked these questions. So do both English speakers and Korean speakers encode the argument structure before speech onset? So that would be according to the hierarchical hypothesis. And whether the difference between the English speakers and Korean speakers still holds when they have to produce sentences with different argument structures and not just transitive sentences. So for the study, I recruited 38 English speakers and 42 Korean speakers, and they were asked to produce 24 transitive sentences and 24 unergative sentences. So I chose this sentence types because in both sentences, the subject is going to be always the agent, but the rest of the sentence would be different. And in the experiment, like it looked the same as what you did in the beginning. So they looked at 3 images, each representing a subject, an action, and an object or location. And these images were presented in the 6 different orders. So the target sentences will be the part at the pair and the artist left on the stage for English. But then in Korean, the order of these 2 constituents will be different. So here for the transitive, the pair comes before it. And for the unergative sentences, again, the stage, which is a location, comes before the verb. All right, so this is the actual instruction that participants saw. And here's an example trial with the eye movement recorded at the same time. And the dependent measures were 2 types. So first, the speech onset latencies. So again, the time it took from the onset of the first image of each trial until participants actually spoke the subject of each sentence. And then the eye movement data for each image during the same time frame. So first, I'll present results from the English speakers. So the speech onset latencies were faster for transitive than unergative sentences. And also, they were faster in the subject first condition. So that means they were faster to start speaking when they first saw the subject image than the verb or the object or location images. And then when you look at the eye movement, participants also looked at the subject image. So that's the red boxes here, the most between the time frame compared to verb and the object images. And again, I also see some difference between the 2 sentence types. So more looks at the verb for the transitive verbs and unergative verbs. So in order to look at more closely when that difference emerges, I also analyze the eye movement over time. So for the conditions where the verb image was presented first versus last. So first you're seeing the eye movements at the verb image when it was the first image of the trial. And you can see that there is no difference between the 2 sentence types. But interestingly, when the verb was the last image of each trial, you can see that the movement, the eye gazes actually diverge for these 2 sentence types with more gazes at the transitive verbs. So that's the red line. And then overall, I found similar patterns for Korean speakers. So again, different speech onset latencies for transitive versus unergative sentences, and also faster speech onset latencies in the subject first condition. And there was no interaction with language. And Korean speakers also looked at the subject image the most. And for the verb images also, can see that the difference is only evident in the verb last conditions and not the verb first conditions. Then I also found some group differences. So overall, when you look at this graph again, English speakers looked at verbs more than objects compared to Korean speakers. And that difference is more prominent in the unergative sentence. So in summary, both English speakers and Korean speakers spent most time accessing the subject lexeme before speech onset and started phonological encoding of the subject when it appeared on the screen. But we also see some differences in both speech onset latencies and eye movements for the two sentence types. So this is more consistent with the hierarchical incrementality hypothesis, which argues that speakers are also sensitive to the different argument structure before speaking. And there's also some group differences that are observed. So consistent with the previous studies, again, English speakers seem to rely mostly on the verb information to figure out the argument structure, whereas Korean speakers seem to use both the object and the verb information. So that was the first experiment. And in the second part of my presentation, I look at the timing of verb activation during comprehension. And here I used a different kind of data and method and analysis, which is spatial similarity analysis on EEG data. And I chose this method based on a previous study. So Hubbard and Federmeyer, 2021, had 4 different conditions structured. So the children went outside to play. So that's where the last word play is most expected in a more constrained sentence. Contrasted by the children went outside to look. So look is in this case less expected than play. And then when we change the subject to joy, which is more kind of like general than children, it becomes weak constraints. So joy was too frightened to move and joy was too frightened to look. And what they found is that when they computed the EEG data between the pre-final verb, so that's the green boxes, and the final words, so that's purple boxes, the similarity between the EEG data at the 2 words was the highest in this SCE condition. So that's blue line on this graph. So this indicates that high spatial similarity indexes pre-activation of the target word. So in other words, when play is very predictable from the previous context, participants would already have this word activated at 2. So based on this data, I used this analysis to examine the timing of verb activation during comprehension in English and Korean. And in this experiment, I used verbs that were unaccusative or transitive. So for this one, I made this choice because for these 2 sentences, the subject has different status. So in the unaccusative sentences, subject is the internal argument of the verb, whereas for the transitive verbs, the subject is the external argument. And in a production study, it has been actually found that verbs are activated at an earlier time than in the unaccusative sentences and transitive sentences because of this difference in their status. So another goal of this study was to see whether this difference in production also shows in comprehension. So Again, I recruited both English and Korean speakers. And during the experiment, they were asked to read different scenarios where the final verb was highly predictable from the previous context. So I'm going to spend some time on how I designed the simile because it's going to be important. So as you can see here, the last part of the second sentence always had the same structure. So here, the beautiful snowman finally melted. So that's determiner, adjective, noun, adverb, and finally the verb. And I use the adjective before the noun to already signal the upcoming noun at the adjective. And the order was the same in Korean for the unaccusative sentences, but then you can see it's slightly different for the transitive sentences because Korean is an SOV language. So here the noun actually comes before the verb, but other than that, the general scenario design was the same. And then to ensure that the last final verb is indeed predictable, I conducted a close probability test in both languages. So I asked the participants, other than those that participated in the EEG study, to fill in this blank after the adjective. And then, so in this case, it would be snowman melted. So you can see that in both languages and for both sentence types, they were highly predictable. So during the EEG experiments, participants read each scenario word by word and answer some comprehension questions at the end while their EEG data were collected. Then for analysis, EEG data were separated into different epochs for each word. So the determiner, adjective, subjective, and the adverb. So those are all the words that come before the target verb. And then finally the verb. And then the spatial similarity of the EEG data was analyzed between the epoch of each word before the verb and the verb. So what I predicted, if the comprehension proceeds in the same mechanism as production, was that you will see the high correlation with the last verb at earlier words for the unaccusative than the transitive verbs. So again, if you look at the English results again, so the relative similarity between the determiner and the adjective was indeed greater for the unaccusative than the transitive sentences, even after controlling for semantic similarity and surprisal. So these graphs show the correlation over time from the word onset until 700 milliseconds. And this graph shows the mean correlation only at this time window, so 160 to 210 milliseconds. And so the darker the color is, the closer the word is to the target verb. So the darkest is the adverb, so that's the word right before the verb, preceded by the subject, adjective, and the determiner. And you can see that this box has a higher correlation than this one, so unaccusative and transitive. But then the pattern was different for Korean speakers. So here the relative difference between the determiner and the adjective did not differ by verb type. So actually the similarity was already high at the adjective for both unaccusative and transitive verbs. So to summarize the results, the timing of verb activation during comprehension is sensitive to the argument structure in English, and this is consistent with the results from the production study. But the timing of verb activation is rather early for both types in Korean, and I speculate that this may be due to different use of memory system owing from more highly frequent verb final structures in Korean than English. And I have the last slide to briefly explain that more. So this is also consistent with some previous studies that compared English speakers and speakers of SOV languages like German and Dutch. So what they found is that English speakers rate 1A, which is grammatical, as equally acceptable as 1B, which is actually ungrammatical. And you can see that although 1A is grammatical and 1B is ungrammatical in both sentences, the distance between the subject and the verb is really, really long, which makes it harder to process the sentences. But then this effect was not found for the speakers of SOV languages. So what has been suggested is that speakers of those speakers experience less difficulty processing those sentences because they're exposed to the verb final structures more frequently. So they may be able to handle the longer distance between the subject and the verb more easily than the speakers of English. So in conclusion, both of my experiments show both cross-linguistic similarities and differences in sentence processing. So during production, both English and Korean speakers showed some evidence of subject selection independent of the verb, but also the structural encoding before starting an utterance. But we also saw some differences in that Korean speakers made greater use of the object information than English speakers. During comprehension, both language groups show some evidence of prediction, like pre-activation of the verb, but the timing was different. So English reflected the argument structure, whereas Korean didn't. So overall, those experiments confirm that word order is a robust factor for cross-linguistic variability during sentence processing. It also suggests that its impact is also influenced by other factors like linguistic and cognitive factors. And that concludes my presentation. Thank you.
Okay, it's a clarification question, so maybe it's good. So thank you. This was very interesting. It's really cool. You can see those little differences, and it's very cleverly designed and everything. So the question I had was about the second experiment. So I didn't quite understand what predicted the differences between English and Korean in that case. And part of it was I was trying to understand what a correlation was. So maybe you could just quickly explain what that is and then say what the differences would be. Why would there be a difference in English between the two kinds, but not in Korean?
So first, to explain more about what the correlation means here. So that's kind of like this. I use this in the same way as spatial similarity in this case. So that's basically the similarity between two sets of EEG data across all electrodes. So how I compute it is just to compute the Pearson's R, so correlation between the two EEG data.
So like the brain looks the same in two different
Right.
times. Okay, I get it.
Right.
Yeah.
And I didn't get into much difference, like cross-linguistic differences in the second part because I thought it's already complicated. But then what I actually predicted in terms of the difference in the two languages was that for the transitive sentences, because verb in Korean, verb comes after the noun in Korean, but then before the noun in English. So I thought I might find actually later timing for verb activation in Korean. But then, yeah, as I showed in the results, that wasn't actually the case. So that happened very early for Korean.
So it's a bit of a mystery then. Yeah, that's interesting. Super interesting. Thank you.
Thank you, Jeonghwa. This is really good. This study is like, this is so eye-opening for me. So I have some just like clarification questions. For the Korean speakers, are they monolingual speakers?
Oh, right. That's a good question. So I don't have very detailed information here, but of course, most of them were English learners as well, but not as fluent, I think, because I recruited them in Korea.
Okay, so then they wouldn't be influenced by their English or like other language background to influence their
Right,
judgment.
not very likely.
So another question is really on this slide. So I was really wondering, like, it is interesting that even though you have those markers to suggest that's an object, but that doesn't seem to have an effect on how they process. Am I getting that idea right?
So for Korean?
Yeah.
Like for the case marker?
Yeah.
Right. So what I think for the Korean results is that because, like in most of the Korean sentences that we are exposed to, the verb comes at the last position of the sentence. I think already at the subject, Korean speakers are kind of expecting the verb phrase as a whole anyways. So yeah, that's one of those speculations that I have, but of course more to be done.
Yeah, so it's just like, I was just wondering like how they kind of process similarly and then also somewhat differently from the English speaker, even though you have some case marker in the language, but somehow you have that knowledge, like overall argument structure that you are building upon. So this is really interesting. I have a little bit more that I can share with you later,
Oh,
but
sure.
thank you so much.
Thank you.
I don't know if I'm allowed to ask a question, but I have a question. In the first set of pictures that you showed us, I wanted to know, am I stupid? I don't know if it's cultural or what, but I read Captain Crunch breakfast. That's the sentence I created when I saw those pictures. And I wanted to know, when you've used that model before, that example, have you had any answers that have been extremely different before?
Oh yeah, that's actually a good question. So for the first experiments, so just not just my experiment, but in most studies that use images for sentence production, there's what is called like training session, where speakers are kind of like exposed to the images beforehand. So they kind of like learn what the images are that they're gonna see later. So I also did that. So what I did was I showed each picture on the screen, so separately, and then just asked them like, what would you call this? Like that. So parrot for this image, for example. But then even so, like in some sentences, there were some utterances that were different from what I intended. And like, so there were two different cases. So if of the participant just used a different word, but then it's still similar to the target word, then I use those utterances. But if the whole syntactic structure is different, then I didn't include that in my analysis.
Okay. I think Daniel. You go first.
I guess, did you have like English speakers attempt weird word orders, I guess, in their responses?
So surprisingly, no.
Okay.
And same goes for Korean. So actually, what I found for Korean data was more interesting because Korean actually has more flexible word order. So for example, you can say, like you can reverse the order and say the pair first in Korean. So I actually thought there will be more variability in Korean data in terms of the word order. Like, so for example, if they saw the pairing first, then it would be more likely that they will start the sentence with pair, but that wasn't the case. And so I was like wondering why that would be the case. And there are some studies that actually show that even if participants have different choices for sentence production in terms of word order, especially, they do not switch the word order during the experiment because it's actually more energy consuming for them to choose between different options. So if they started with one choice, then they would just stick to it during the whole session.
Thank you, Jeonghwa. Great work. I actually just want to ask a clarification about the expected and unexpected in the second experiment and what exactly counts as expected, unexpected there. Is it just a similarity in the semantic representation of the two verbs, but not a connection in terms of their more specific meaning?
So can I ask whether you're asking about this?
Yeah, exactly. Yeah.
So I'm sorry, what do you mean by?
So about the expected and versus unexpected. So it's basically just the some of the semantic features of the verbs, right? That you have a motion verb in the first predicate and then a motion verb in the second one. That's all that it's actually making reference to, but not the notion that the first verb would prime the second one in a more specific way. Is that right?
So
the children went outside to play, right? That's the expected case.
right.
And is the expectedness just the identity in terms of the two verbs being verbs of motion?
Are you talking about these two?
Yeah, the contrast between expected and unexpected.
So I think what makes a difference in this particular case is the fact that the subject is the children. So
Okay, sorry, that's what I missed.
That they'll be going outside to play than to look.
Okay, all right, good. Thank you. Yeah, all right. That because there was also the issue about the verb, the identity between the predicates in terms of being a verb of motion or not. But this is just in this example. Okay, the other ones will not have that. All right, thank you. Appreciate it.
Any other question? Okay.
Thanks. So I'm curious about in the first experiment, the task that people were doing. You looked at gaze at the different pictures, right? And that was part of it. Can you say something about what you're assuming links the gaze to the planning in that case?
All right.
What does that mean? You know, what part? Yeah, how is that brought in exactly?
Right. So there's two aspects in terms of the connection. Well, I don't have an appropriate graph, but so first is when you are planning to say something, the gaze will almost always kind of like precede the words that you're gonna say. So for example, for the sentence, the part A, the pair, like, because the sentences start with the parrot, right before the speech onset, you will see eye gazes going up for the subject image. So that's one aspect. And during the planning session, what I assumed is that so basically the eye gazes would reflect the type of processing. So when you look at the subject image more during the processing, then I thought that reflects the processing of the subject image in their head.
So there's a lot of things that are going to go into that, right? Part of it will be figuring out how that fits into the sentence, but is part of it also they're trying to figure out what the picture is depicting? Maybe there's different lexicalizations for that particular picture. That all fits into it.
Right.
So, but can we be confident that the planning regarding fitting it into the argument structure of the clause is, you know, that we're assuming the right thing about that by connecting the
So
gaze
because
relation
of
to
that, I mean, this manipulation still may not be sufficient to 100% resolve that confounding problem, but so like when making the stimuli, I made sure that for example, word frequency and word length of the words in the two different sentence types at least match. So yeah, so as to minimize a possible confound coming from that different processes for lexicalization. And for the analysis, I also excluded those trials that had extensively long speech onset latencies, which I thought would reflect either maybe the trial was just too difficult for them to figure out like the sentence to say, and maybe like some images were more difficult to lexicalize than others.
Thanks.
Questions? All right, thank you. Thank you for all the questions.